Good afternoon, ladies and gentlemen. I have a number of troubles and embarrassments, quite apart from the fact that I seem to be the only person not wearing a coat and a tie. One of my big problems at the moment is that I'm supposed to give a scientific talk, as you can see from the title of the talk. I was going to give a scientific talk, and what turns out to be a session on politics of climate change, which is a bit of a problem. An even bigger problem turns out to be the fact that Dick Lindzen at lunchtime more or less told you everything that I was going to tell you, only he told it so much better. And so I'm not quite sure what to do, particularly as Myron here took it into his head to quote from the President Eisenhower's speech, which is again exactly what I was going to do for you. And I was also, believe it or not, going to quote from Gulliver's Travels, and so I'm left with very little else to do, and so I may have to change the topic, and I will change the topic to something else instead, and that will consist of me thinking up some random thoughts as I speak, hopefully that have not already been thought about by Dick Lindzen. First random thought is that I want you to think about the smoke rising from a cigarette. And if you've all will have seen it, I imagine, at some stage, and for the first foot or two, that stream of smoke is steady and perfectly predictable. And then all of a sudden, the stream of smoke breaks up into a stream of eddies. And these eddies, let us imagine, are in some sort of a flue or a chimney. And the point about these eddies is that they are turbulent, which means, in effect, that they are inherently unpredictable. And you say to yourself, why are they unpredictable? And it is because you can make a whole series of measurements all over this field of eddies, and you can make the measurements as close as you like. Nevertheless, when you try to use those measurements to predict what will happen to the eddies in the future, what happens physically is that there are eddies even smaller than the distance between the measurements, and those very small eddies grow and suddenly appear out of nowhere as they get bigger than the size of the distance between the measurements. And those unknown growing eddies completely make a mess of any prediction that you are trying to make. And about the only thing that you can predict about that rising plume of eddies in the chimney is that they will continue to rise. You'll be able to say, with a bit of luck, you'll even be able to say what the speed of rise of the average eddy shall be, what the average rate of rise shall be. But you won't be able to say anything at all about the detail of the individual eddies. Now, all of that nonsense is simply to lead you, or me, to the point of telling you that, as what you probably already know, is that the climate system of atmosphere and ocean is, whoops, what have I done? The climate system of atmosphere and ocean is very much like that field of eddies, except that it is much more complex. The atmosphere and the ocean are two separate turbulent media with turbulent processes going on inside them, and in a sense, all these eddies are probably unpredictable. The difference between the smoke plume that I was describing to you and the Earth system is that there are a whole stack of different boundaries which may or may not allow you to make predictions of what will happen to the eddies in the atmosphere and ocean over sizes that are actually smaller than the size of the Earth. And so in principle at least, if not in practice, scientists ought to be able to predict what will happen to the average climate of the Earth, the average temperature of the world, the average rainfall of the world. But as it gets less and less likely that you will be able to make any sensible predictions as you try and predict things at a smaller size or a smaller scale, as they say, than the actual total size of the Earth. And if you like to take a rough guess, you would probably guess that you ought to be able to say something about the average behaviour over areas the size of, let us say, the ocean basins, things like the Atlantic Ocean or the Pacific Ocean or whatnot. But if you try and make predictions of what will happen on a much smaller scale than that, the chances are it would be inherently possible so to do. Now, lots of people recognise that fact, but climate scientists persist in creating models which attempt to predict what will happen on scales or sizes much smaller than that. And indeed, I have seen forecasts of the change in climate that will occur at individual states of Australia, for instance, is where I come from, in case you didn't guess, or the individual states of America. The bottom line is that it is probably, I won't say certainly, but it is probably inherently impossible to make forecasts, long-distance forecasts of the change in rainfall, for instance, over areas as small as the continent of Australia. Forgive me for talking about Australia, but I know something about that. This restriction hasn't stopped scientists from trying, and indeed we are flooded in our country with forecasts of the fact that the rainfall in northeast Victoria, and Victoria is one of our small states, is going to get more over the next century, and the rainfall in the southwest of Victoria will get a lot less. And this sort of information is fed into the plans of the various states of Australia as to what they're going to do about this frightful, forthcoming, disastrous climate change. The fact that they are probably talking nonsense in their forecasts seems not to worry anybody. We had, in fact, a year or so ago, an economist who was given the task by the Australian government to determine what would be the impact of climate change on Australia in the next 100 years, and therefore what we should do about it. And he was fed one of these forecasts by one of these climate models, and that particular forecast came up with the idea that southeast Australia would get a lot drier. Southeast Australia is where we grow all our food, and thereby Australia in 100 years' time would be much worse off, and indeed the average standard of living of the average Australian would go down by 10 to 20%. Now this forecast was taken seriously, and it was taken seriously by the economists, and as a consequence it formed the basis of the attempt by the Australian government to bring in a, what do they call it, an EST scheme, ESP? Emissions trading scheme, which so far the attempt has failed, so far anyway. But where was I going with this random idea? Oh, the point being that he, as I say, estimated that Australians in 100 years' time, if nothing is done about climate change, will be 10 to 20% worse off, but worse off than what we would have been if there had been no climate change. Fair enough. But somewhere towards the end of his report, he also made the point that had there been no climate change over the next 100 years, then the average Australian will be 400% better off than he was or is now, which means that if you carry through the logic, in 100 years' time, the poor average Australian will only be 350% better off than he is now, which is a terrible thing. But what he is asking the average Australian to do, he being he and the following government, is to put the average Australian's hand in his pocket to pull out money to give to somebody in 100 years' time who is 3.5 times better off than I am. And this is something which I think is worth at least considering as to whether one really should do anything about climate change, at least in Australia. So that was the first random thought that at least Dick Lindzen didn't talk about at lunchtime. Dick did talk about feedbacks, and he made the point, and it was a point I was going to make, is that it is true that if over the next 100 years the world, or the humans in the world, double the amount of carbon dioxide in the atmosphere, then it's fairly easy to calculate that if nothing else changes, then that doubling of carbon dioxide will probably lead, or in fact will lead, to a rise in the average temperature of the world of about 1 degree Celsius. The twist to it being that if nothing else changes, and of course what does happen is that if the temperature starts to rise, that will affect other things, and it will change things like the amount of water vapour and the amount of cloud in the atmosphere, and this in turn will change the surface temperature of the world. And the funny thing is that all these feedback processes that we hear about, this amplification of the original 1 degree due to the fact that CO2 increases or doubles, all these feedbacks seem to be positive. That is to say, would make the situation worse. And so the water vapour feedback is supposedly positive, the cloud feedback is supposedly positive, the feedback due to decreasing area of ice on the surface, that feedback is positive. And so all in all, we are in deep trouble, and the models therefore predict that the temperature, instead of rising a measly 1 degree Celsius, may rise anything between 2 and 7 degrees Celsius, which I must admit, if true, would make us think a bit. Now, I think the point I wanted to make was that these model predictions are based on feedbacks which are determined by what happens not close to the ground, but up high in the atmosphere, above, let us say, 3 kilometres and above. And it just so happens that the present-day measurement capability of balloons and instruments on balloons and instruments on satellites simply cannot measure accurately enough the amount of water vapour and of cloud, and specifically of the changes in water vapour and cloud that take place at those altitudes above 3 kilometres height. And so there is no way yet of determining whether or not those feedbacks are positive or negative. The measurements are simply not accurate enough, and so we can't actually verify the models. And so there are new satellites going up at the moment, and given 30 years or more, we may indeed be able to solve that particular problem and determine whether the feedbacks are positive or negative. But at the moment, we can't do it. And so it is still entirely possible that that original 1 degree rise in temperature I was talking about won't be 2 to 7 degrees, but it may in fact be half a degree or less. So that was the second random thought. The final random thought gets away from the science a bit, and may I ask you to think about the Middle Ages, when the Church in general was not terribly happy with the idea of translating the Scriptures and the Bible into the local languages. And the reason for that, so we are told, is that the Church and the priests of the time were rather fond of their jobs, and they would be out of a job if they weren't required to do the translation of the Scriptures for the average man. Furthermore, if they didn't have to do the translation and the average man could also read the Scriptures, the average man could interpret them in the way he liked, rather than how he was told by the, let us call them the educated ruling class, if you like, of the priesthood. The modern climate research fraternity is a bit like that, a bit like the priests of old, that they are rather reluctant to hand over the interpretation of the science of climate change to the man in the street, and particularly to the skeptics and the scientifically literate skeptics in the street. And as a consequence, because most skeptics have to express themselves via weblogs in this day and age, the climate research establishment is very reluctant indeed to give any credibility at all to information that gets discussed on the web. Now, the bottom line is that there is a vast resource out there in weblog land of scientists and amateur scientists who could, if they were treated right, be used as a resource to help with the analysis of data and the analysis of models and so on and so forth. And it would be good if somehow or other the climate establishment could reach out to the people in weblog land who could indeed help them make unbiased analyses of climate data and climate model data. And so, if anything else that comes out of this overall conference, what I would like to see is a recommendation from the conference to let us say the climate science fraternity, that they reach out to the amateurs and the non-amateurs, the specialists, if you like, the specialist scientists on the internet who have to express themselves on the internet, reach out to them to try and make use of what is a vast resource. There's a vast resource of people out there who can contribute to the whole idea, a whole game. I better stop there because I've run out of not only ideas but of time. Thank you very much.